I welcome you to another session where we look at the empirical formula of a certain compound. We want to look at question 12 today from the tutorial sheet that is saying determine the empirical formula of the compound with the following percent composition. The first percent of carbon, 6.7% of hydrogen, and 53.3% of oxygen. We want to look at how we can find the empirical formula of that compound. And of course, before we do that, we really have to define and know what an empirical formula is. How does it work? What do we mean when we say the empirical formula of a compound? So it's quite very easy. I'll just make sure that the work becomes very easy for you. I'll simplify the whole term so that we can have a better view about the empirical formulas. So when we talk about the empirical formula, what we simply mean is this. So let me write something from here. So just the word itself, empirical formula. The other word that we can use just to define and give a brief descriptive composition of the empirical formula, we would say the simplest formula. We'll just say the simplest formula. So you can look at a compound. Maybe you've been given a compound such as this. You've been given a compound such as C6, H12, O6. Okay. And then they tell you to say, write the empirical formula of this compound that is here. So what they're trying to emphasize is that the empirical formula of a chemical compound is the simplest or number ratio of atoms present in that chemical compound. So there is what we call the subscript. This number below the carbon here is a 6, and this number below the hydrogen here is a 12, and the other number below the oxygen is a 6. So these numbers here are called subscripts. So now you know that these numbers here can be written in the lowest terms. We can still find the lowest term in which we can write this empirical formula here, in which we can write this compound that is here. So this is C6H12O6. So to simplify everything here, this can also be written as CH2O, because you know that the 6 into 6 you get a 1 there, 12 into 6 you get a 2, and 6 into 6 you get a 1. So I've just written the simplest way of writing this compound here into that. That's why I'm defining an empirical formula as the empirical formula of a chemical compound is the simplest or number ratio of atoms present in that compound. So these are the ratios of the compounds: carbon to hydrogen and hydrogen to oxygen. So what is the simplest way of writing these ratios of these subscript or numbers that are here? So this is the simplest way of doing the work. So we just want to find out how can we work out, or how can we find the empirical formula of a certain compound. And in this compound, these are the certain percentages that we've been given. So I think let's work out the question and see where we can land. Okay, so these are the answers to the question that has been given here. So remember, we've been given the carbon, we've been given the carbon, we've been given the hydrogen, and we've also been given the oxygen. So the percentage of carbon is 40%, that is 40.0%, and the percentage of hydrogen is 6.7%, and the percentage of oxygen is 53.3%. So this is just emphasized to say this is 53%. Okay, so we've been given individual percentages of each and every atom that is present in this compound. So we want to find out what is the empirical formula of this compound. The steps are quite easy. We first want to get rid of these carbons, this carbon here. We first want to get rid of these percentages that have been given in this carbon, in the carbon atom, in the hydrogen atom, and in the oxygen atom, because a percentage is just showing you the amount of carbon that was present in this compound, or the amount of hydrogen or oxygen that was present in this compound. In other words, the amount that talking about the masses that were present in here. So we can equally say this is just the masses, or the amount that was present in this compound. We had 40% of carbon that was present in this compound. We had 6.7% of carbon that was present in this compound. And we had 53.3% of oxygen that was present in this compound. So here we've got the 40, so I will still indicate that. And then we've got the hydrogen here, and then we've got the oxygen. So here we still have 40.0%. So I'll remove that because we're looking at the amount. So it's just that we have 40.0 grams. So here 6.7 grams, and there we have 53.3 grams. So the next step, you divide by the molar masses here. The molar mass of carbon, the molar mass of hydrogen, and the molar mass of oxygen. So when you divide that, we know that for carbon, we've got 12.0107 grams per mole. We want to find out the number of moles that were present in this. And then here also, we've got the molar mass of hydrogen there, 1.00784 grams per mole. And then the last one here is oxygen, and we've got 15.9994 grams per mole. So I'm using the recommended periodic table that was given by the chemistry department under the University of Zambia, and these are the values that we're supposed to use. Of course, when you get back to secondary school, say the molar mass of carbon is 12, the molar mass of hydrogen is 1, and the molar mass of oxygen is 16. So, but here there's a periodic table that we use, and it is very much recommended for the sake of accuracy and precision of our numbers here. So let us focus on that. So we're still moving here. Let us find out the value that we're here. We're dividing 40 over everything, 6.7 over everything, 53.3 of oxygen over the 15.994 grams per mole. So let us find out what we'll have from here. So there's this carbon here, we still have hydrogen here, and we still have oxygen here. What moles are we going to have? So here we've got 3.3, 303, 63, 7, 5, 9 moles. And here we've got the value of 6.6479 moles. And here the moles of oxygen are 3.3137497. So this is equally, these are the number of moles. So when you divide the masses over the molar masses of those carbons, like we did on the previous step for carbon, for each individual atom, for carbon, for hydrogen, and for the oxygen. So when you have these moles that are here, we can now divide by the smallest number of moles for the atom with the smallest number of moles. And when you check out the numbers here, we can start from the hydrogen. This is the highest number here, followed by which other number here, and followed by this number here, because when you look at the arrangement of these numbers, this number is slightly bigger than the moles of carbon. The moles of oxygen are more than the moles of carbon. So this is the smallest number that we have here. So we can divide throughout. So 3.330363759 moles. And then we also divide 3.330367359. And then also we can divide 3.330633759. We're still moving on. And then so from here we still have, and we're still going to maintain the carbon, we're still maintaining the hydrogen, and we're still maintaining the oxygen. So when you divide throughout, this number on top here, the numerator is equal to the denominator. So of course, when you divide that, you just get a 1. From here, when you divide that number, I'm getting a 2 here. And then when you divide that number, I'm getting a 1. Of course, you might have other numbers after the 1, but ask yourself, if I round off those numbers, am I still going to get something above 1? Or the number after the 1, is it greater than 5? If it's greater than 5, you can still round off to get to a 2. But the numbers after the 1 are just less than 5. So we just maintain an O number here, or a O number there. So it's just fine. So then we can write the empirical formula of this compound. So now you know that the empirical formula of that compound per subscript. Remember, I mentioned to say the numbers for each atom are called subscripts, and we're trying to find and simplify them to the lowest terms. So C here, we can't indicate the 1. The hydrogen there has got a subscript of 2, and the oxygen there has got a subscript of what? Of 1. Of course, we can't indicate it there. So this is how you get to find the empirical formula of the compound. I'll repeat myself. The empirical formula of a chemical compound is the simplest O number ratio of atoms present in that compound. So we're just trying to find the simplest way of writing the individual ratios or the subscripts of that chemical compound. And we just found out that the chemical or the empirical formula of the compound we're looking for is CH2O, and that is the final answer. So we're done with the empirical formula, and later on we want to look at how we can find the molecular formula of a compound. So we'll discuss that in the next video. Thank you so much for paying attention, and we look forward to interacting with you. Thank you so much.